Yeah, so, so we're gonna move on to example 9, determining the domain of radical functions. So again, this goes back to, this one just went back to Pythagorean. And again, remember, instead of 6, we used 12, because 6 times 2 is 12, and 8 times 2 is, are 16, which brings us to this sentence. Alright. Hmm? We're going to determine the domain of radical functions. So, by the way, one more time for those of you that came in a few minutes later, I updated the test, obviously, the 3 tests up to test 4, and also your homework. So please make sure you check where you're at. And remember, the class ends on February 28th. Try to make it here on time so you can start your test on time. And bring your laptop, yes.
Oh, you put 0 and I didn't, can you update it?
I updated it, don't remember. I don't know, take a look and see if I did or not. Okay, so for this, we're going to find the interval. We're going to write the domain in interval notation. That's the other thing we're doing. So, okay, so they're giving you g of t is equal to the 4th root of t minus 2. Now, by default, it's as simple as this part can never be what? Because it's an even, right? It can never be a negative. So, if I have t minus 2, that value has to be greater than or equal to 0. So t always has to be a number greater than or equal to 2. So my domain in interval notation is simply going to be 2 comma infinity. Remember, infinity is always a parentheses closure. Okay, now the reason we use this process is because that is a 4th root. It's an even root. If that were not an even root, we could not use this step or this process. Alright, and I'm going to prove it to you with the next example. So, in the next example, I have h of a is a cube root of a minus 3. What do you know about cubes? It could be negative. It could be negative. Because this is an odd number right here, the domain is all real numbers, which we know in interval notation is negative infinity, positive infinity. Yep. That's the answer. All real numbers, which is from negative infinity to positive infinity. Again, just to solidify this explanation, that number, look at where I'm circling like a neurotic, that has to be odd. It has to be a 1, a 3, a 5, 7. It has to be an odd root. This one is an even root. Because it's an even root, we can apply this process. This one is an odd root, so because it's an odd root, we have to apply this process where we know it's from negative infinity to positive infinity. And proving it, for example, if a is 30, that will give me the cube root of 27. We're good. If this were a is negative 24, this gives me the cube root of negative 24. It's still a root of negative 3. Right? Because if I did cube root of 30 minus 3, don't I get the cube root of 27? And isn't that just positive 3? Okay. So what if I have the cube root of negative 24 minus 3? Then what I really have is the cube root of negative 27, which is negative 3. because it's cubic. That doesn't work if it's an even function. Okay, you think you got this? Can we stop here? Alright, let's stop here. One second, let me stop